All right, number 3. So yeah, this is actually a good one. I mean, it's a tough one, a good one to spend time thinking about, being careful. Okay, so they give us this function right here, and they want us to find the y-intercept, the x-intercept. What happens is x goes to infinity and negative infinity. Okay, well, we talked about earlier how you find x and y-intercepts. Let me go back to the notes for you. It's in the notes. I know there's a million things in the notes, but there's been a million things we covered. Intercepts. There it is. So finding x and y intercepts, this will come up all the time, and so it's something, it's helpful if you just kind of like know it off the top of your head, because it will be coming up again and again and again all semester. There we go. All right. So finding x and y intercepts. This is for any equation, anytime. What do? To find x and y intercepts, to find an x-intercept, you plug in y0 and solve for x. To find a y-intercept, plug in x0. So you see how you just plug in the opposite letter 0. To find an x-intercept, you let y be 0. To find a y-intercept, you let x be 0. You let the opposite letter be 0. Okay. So let's do that. So coming down here, to find this y-intercept, I'm going to plug in x is 0. You always plug in the opposite letter 0 to find an intercept point. So, okay, so how am I going to do that then? Well, it says, where's y first off? Well, this is y, isn't it? Remember, the function is always y. So this is y equals, you plug in 0, you're going to get 0 squared plus 0 cubed minus 42 times 0. That's going to be y equals 0, isn't it? Now, for a y-intercept point, they want both the x and the y, so the answer is going to be 0, 0. How did I get that? Well, we plugged in x is 0, so your x is 0, and y came out 0, so that's also 0. So the actual intercept point is 0, 0. They want an actual point there, which means two numbers with a comma in the parentheses, the x and the y. Now, x-intercepts. What are the x-intercepts? To find x-intercepts, in fact, let me just bring, I'm not going to have room right there at all. So let's come down here. To find the x-intercepts, we're going to plug in y as 0. Plug in y as 0. So I take the equation that they gave me, that p of x equals x squared plus x cubed minus 42x. And all right, so you guys with me? This is the hard part. This is for sure the hard part of this question right here. So to find the x-intercept, plug in y0. Again, where's y? Remember, the function is the y. So that becomes 0. Okay. And now I've got to solve that equation for x. This is where most people get confused. It's an algebra thing. It was covered in intermediate algebra, but I understand most people are rusty or haven't had it at all. I'm glad to help you with it, to review. This is the kind of thing I definitely want to do with you, because I know this is the kind of thing that gets in people's way. So I'll go through it once, but please, you're not bugging me at all. If you want to talk about it some more and do it some more, I'm glad to, because this is really what will really help you is things like all the algebra rules like this. This is what helps people go forward strongly, is having good algebra knowledge. All right, so let's go through it slowly. What do we do? First step, I'm going to reorder. Highest power to the, highest power to lowest. So we'll go 0 equals, so I'm going to put the higher power first. So this x cubed has to come first. So that's better. So we want to put them in order. So third power, second power, just first power, right? From highest to lowest. Okay. Then what? Step 2. Factor to the front what is in common and put one big parenthesis. So step number 1, reorder. Step number 2, factor to the front. Okay, as you look at x cubed, x squared, and 42x, what do they all have in common? What do they share? Well, an x, huh? They all have an x. Put one big parenthesis, right? That's called the greatest common factor. Put what's in common in the front. Put one big parenthesis, and then put inside whatever you need. What do you mean? What do you need? Well, x times what? And we're going to have 3 things here, right? With a plus sign between and a minus sign between. X times what will go back to x cubed? I need x squared, right? Because this is an invisible 1 power here. So x to the 1 times x squared, remember powers add, that'll go back to x cubed. Okay, what do you need in the next spot? X to the 1 times what will go back to x squared? Well, just x to the 1, or just you don't even have to show the 1. Just regular x will do it, because the what? The 1 and the 1 will add to be 2. And finally, x times what will go back to 42x? Well, just 42. Right? When the x hits the minus 42, that'll go back to minus 42x. So we factored out whatever was in common with one big parenthesis. Got it. Okay. Now, step 3. Here's probably the hardest step. Step 3. Factor x squared plus x minus 42. 2 parentheses, x is in the front. Remember this whole thing where you have to factor and you have the 2 parentheses x in the front, and you say, okay, whatever number, we're looking for 2 numbers that multiply to be minus 42 and add to be what? Plus 1. So what are 2 numbers that multiply to be 42? What multiplies to be actually minus 42? Well, 6 times 7. But you could have the plus on the 6 and the minus on the 7, or vice versa, huh? How do we know which one of those is right? Well, it has to add to be plus 1, doesn't it? Which one of those? They'll all multiply. They multiply to be minus 42, don't they? Just put a comma here. They multiply to be minus 42. What do they add to be? These guys would add to be minus 1. These guys would add to be plus 1. That's the right pair I want. Do you see that? Because minus 6 and plus 7 add to be plus 1, don't they? So minus 6 and plus 7, those add to be plus 1, which is what you want. You got to add to be the number in the middle. You're looking for 2 numbers that add to be the number in the middle, and they multiply to be the number at the back. So that's my right pair of numbers. And it doesn't matter what order. You could totally put the x plus 7 here and the x minus 6 there. That's fine. The order does not matter, but the signs in front do matter, right? Wherever the 7 is, he's got to be the positive guy. And wherever the 6 is, he's got to be the negative. Why? Because plus 7 minus 6 adds to be plus 1. If you switch it, you mess it up, because plus 6 and minus 7 adds to be negative 1. That's not correct. We're supposed to add to be plus 1. So either order, as long as the 7 is positive in front of him and the 6 is negative in front of him. Okay, so where does that put us in this problem? Well, so then number 3, 0 equals, we have the x in the front, and then now we have the 2 parentheses from the x squared, x 42 thing, we have x minus 6, x plus 7. So we factored it down for that. X in the front is still there, though. That hasn't gone anywhere, right? That's still there. It's just the other 3 broke into these 2 parentheses. The 0 is still on the left. Everything else is still there. It's just these 3 broke into 2 parentheses. Okay, now what do we do from there? You set each part separately equal to 0. What do you mean? You take the x alone. Well, here, let me write what I'm doing. Step 4. Each part equals 0. And solve. You take each part. Why? Because there are a bunch of things multiplied together. X times x minus 6 times x plus 7. They're all multiplying. If I said, hey, I'm multiplying a bunch of things. If any one of them becomes 0, then they're all going to multiply to be 0, right? You multiply a bunch of things and one of the numbers is 0, the whole thing's 0. So the x alone is 0. Next, the x minus 6 is 0. And last, the x plus 7. See how I set all 3 of them to 0? Because if any one of those becomes 0, then for sure they're all going to multiply times to equal 0. All right, let's solve it. So this means, come on down, add 6 to both of those. These cancel. So x is 6. Subtract 7 from both of those. So x is minus 7. And the 0 is done. So we have 3 answers. The answers are 0, 6, and minus 7. Those are the 3 answers for x. Now, careful, they wanted x intercepts. So those are the answers for x. Yes, I should say here. Yeah, let me write that better. So the answers for the points, because these are points, because we have x is 0, y is 0, right? And then x is 6, y is 0. These are all going with a y0. You see that? X, y, x, y, x, y. Like that? What? Why? Why? Because remember back in the beginning, we plugged in y is 0 right there. We made y 0, and then we found all this x stuff coming from that. So it all comes from y being 0. Y is 0. So each of these x answers, 0, 6, and negative 7, they all go with a y0. See how each of them go with a y0? Because they all come from a y being 0. And you got to put commas between them. And so that's our answer. There we go. Oh, and we still got to finish the rest of number 3. This is a long problem. All right, so we found the x-intercepts. What are they? 0. Here, let me make the colors a little more clear. 0, 0, 0, I don't remember. Oh, 6, 0, and negative 7, 0. 6, 0, and negative 7, 0. There we go. So we found the x-intercepts, we found the y-intercepts. Now finally, we've got to do the infinity thing. Well, remember, all that matters for the infinity thing is the most powerful term. So see if I can just squeeze it in right here. So, yeah, I think I can. Okay, so the most powerful term, I'll try to draw another line between them here. Okay, and so the most powerful term in this thing is the x to the third. So that's all that matters. When you're plugging in infinity, which means you're going way off to the right. This is in the notes also. Let me show you in the notes. Down here much further. There it is. In behavior of a function. Yeah, so there's in behavior. How do you find the in behavior of a function? Well, I'm giving you the details right here. Let me just go up here and do it. So right here. Okay, so as x goes to infinity, on the graph, this means x goes right forever. That's what it means, because this is the x-axis, right? This is the x-axis, and so if you go right forever to infinity, as x goes to infinity, that means right forever. And what does f of x do? Well, as you go to the right on this graph, it goes down, doesn't it? This one goes down. Or another, and then mechanically how you do it is you only need to plug into the highest power term, which is this one. See how I only plugged in to that guy? That's all I did. I just plugged into that guy. The ninth power is a higher power term than the seventh power or the second power or this one that doesn't even have an x, right? The ninth power, that's the most high power term. So that's all I plugged into there. It's all you need to plug into. Okay, so that's what's happening here. I can just take that infinity and I can just say, okay, y will equal infinity to the third power. He's the most powerful term. Highest power term. And so what's infinity to the third power? That's infinity. So positive infinity, which means as x plugs in, goes to infinity, y is going to go to positive infinity also. And then down here on this one, we're going to let x go to negative infinity. So we plug in negative infinity, same thing, just the most powerful term, just this guy right here. It's going to be negative infinity to the third power. And that's three negative signs, isn't it? That means negative infinity, negative infinity, negative infinity. Three negatives is negative, isn't it? So it's negative infinity. So this is negative infinity. Is that making sense? That's negative infinity. So all you have to plug into, you don't have to plug into the x squared or the minus 42. So why not? Because this is the most powerful term. He's the highest power. So he's going to dominate them when you plug in really big numbers. If you're plugging in infinity or negative, that's like 10 million. That's like negative 10 million. Those are very large numbers. And so all that's going to matter is the highest power term. The third power term is going to dominate the scene. It's bigger, more powerful than the second power and the regular x. Third power is more powerful. So all you need is the highest power. The highest power, because that'll tell you the story. He will take over. He's in control over the lower powered ones. So just plug into the highest power and the highest power. Find out what he's doing. Positive infinity, negative infinity. Positive infinity, negative infinity. You know what the story is. That's what the function has got to eventually do as x goes to the right forever, positive infinity, or to the left forever, negative infinity. There we go.